Okay, just picking up where we left off here, we were about to do a full example kind of a significance test, testing a claim about a population proportion kind of from beginning to end using this PHANTOMS acronym. And this is talking about Benford's Law and sort of fraud that takes place sometimes in businesses. It says when the accounting firm AJL and Associates audits a company's financial records for fraud, they often use a test on Benford's Law. It says Benford's Law states that the distribution of first digits in many real-life sources of data is not uniform. In fact, when there is no fraud at all, there's expected to be about 30.1% of the numbers that are in a business's financial records that should be beginning with the digit 1. It says if the proportion of first digits that are 1 is significantly different from 0.301 in a random sample of records, then AJL and Associates is going to audit that company more thoroughly. Suppose that a random sample of 300 expenses from a company's financial records results in only 68 expenses that begin with the digit 1. Should AJL and Associates audit this company? Run a significance test at a significance level of 0.05. Okay, so one thing we should note here is it says the random sample was 300, so we know N is 300. Okay, also just mentions here that 68 of them were beginning with the digit 1, so this is kind of what our sort of our P hat, our sample proportion value is. Okay, so what we're measuring is a claim about P, the true population proportion of expenses, okay, beginning with a 1. Okay. And so the null hypothesis is supposed to be the one of equality. And so it says up here in the problem, when there's no fraud, they expect to have 30.1% or 0.301. Okay? Now it didn't really mention a direction. It actually just said here, if the first digits that are 1 is significantly different, meaning if it's less significantly or much lower significantly, then those are both causes to maybe audit the company. And so here's an example of what's going to be a two-tailed test. The alternative is just going to be that it does not equal 0.301. Okay? This is also the step, the H step, is where you would list the alpha level, which they told us that. By the way, if significance tests don't name one, you're allowed to pick one. Typically 0.05 is just the default that most people pick. Okay, so we can run through these pretty quickly. These are our list of assumptions. That's what the A stands for, which is what our conditions were. It says here random, that there were 300 expenses were randomly selected. Okay, so we just kind of list that. Okay, the 10% condition for independence is 300 times 10, that would be 3,000. Okay, for this company, we could expect that 3,000 expenses would definitely be less than or equal to all the expenses at the company. Okay, okay, and then our normal, if you want to call it a large counts condition, okay, this is where we're supposed to take N. Remember up here we said N was 300. Okay, times P. We get the P from right here, what the p-value is from the null hypothesis. We need to make sure that this number is actually going to be greater than or equal to 10. Okay, also I need to do 1 minus that, okay, so that the failures as well, whoops, sorry, this is a 7 here, 209.7, obviously greater than or equal to 10. So we're checking off all those, that's great. Okay, we're going to name the test. This is a 1 proportion. By the way, 1 stands for we took 1 sample. Okay, later we're going to look at taking 2 samples and comparing them together. So that's what the 1 is, 1 proportion Z test. Okay. All right, so the T is where we get our test statistic. This is where we get our Z-score. And I'm going to go ahead and write down the formula just because you know, we might not be as familiar with it right now. Whoops. But you normally are discouraged from actually writing the formula down with the variables in it, because if you miswrite something, they dock you for that. They prefer that you just kind of plug the numbers into the formula, and that's how you write it. Okay, our sample proportion, remember that came from right up here, the 0.227. Okay, minus the p sub 0, that comes from the null hypothesis. We're going to divide that by the square root of, we're again using those numbers from the null hypothesis here, and our n value is 300. Okay, that typed in gives us a z-score of negative 0.279. Okay, now here's where I'd like for you guys to get into the habit of drawing the curve. They really like that. They say that that's great communication. So if you're ever on the edge in the rubric, they'll kind of give you the benefit of the doubt. They look for those extra elements kind of just communication. They consider these graphs that. Okay, so let's see. So this is a two-sided, remember. It was a does not equal to. Okay, so if I'm just talking in terms of z-scores, we know z-score in the middle is a 0. Okay, so I want to go 2.79 to the right. So I don't, maybe roughly right here would be 2.79. Okay, roughly right here might be negative 2.79. I'm going to shade to the left. I'm going to shade to the right. That's my two-tailed or two-sided test. Okay. Then down here for me to actually, the O is obtain the p-value. Okay, obtain the p-value. So when I get the p-value, I'm going to use the calculator, normal, CDF. Okay, now I technically need to be multiplying this by 2. Okay, I can choose whichever tail I want to calculate. I'll do the right tail. So 2.79 comma 10,000. Okay, and then I'm going 0, 1, because I was speaking in terms of z-scores here. So this is my lower, this is my upper. Okay, I type that in the calculator. I get, let's see here. I think I get something close to like 0.0026. Okay, but that's only one tail. So I really need to technically multiply this by 2 so that my p-value is 0.0052. Okay, 0.0052 there. Okay, so now I need to make a decision, and my decision is going to be, since the p-value, which is 0.0052, is, I'm comparing this to an alpha level of 0.05. So since it's less than an alpha level of 0.05, my conclusion is we reject the null hypothesis. We can say we have convincing evidence that, okay, and then you can go back up to your P if you need to and look at what did we define to be the parameter that's in question. That's the true proportion of expenses beginning with a 1. So we can say that the true population proportion of expenses beginning with a 1 is, okay, remember we're kind of always talking about the alternative. Now that was the does not equal to, so we say it is different than 0.301. Okay? And if you wanted to have great communication, you should suggest that AJL then should consider auditing this company. Okay, they should consider auditing this company. Okay? All right, it mentions here to just kind of explain, hey, what does that p-value of 0.0052 mean? And this is really similar to question 51 that's going to be on your homework, okay? And when you're given these p-values, the assumption is, look, assuming the null hypothesis is true, okay? And that means, in this case, the true proportion is 0.301. Okay, so assuming that null hypothesis is true, in a sample size of 300, there is a 0.0052 chance of getting a sample proportion of, Okay, remember this was the sample proportion that we had gotten, the 0.227, or more extreme. Okay, more extreme is referring to going farther back into these tails. Okay, so that's what the p-value means there. Okay, all right, just the last thing I just want to look at here with you guys is on this next page, it references us now using our calculator to just really quickly construct a 95% confidence interval for this exact same problem, and wanted us to check to see, is 0.301 actually in this interval? Is that 30.1% in the interval? Okay, so here's the data we need. If you recall, and you're just going to do this on your calculator here. This would be called a 1 proportion z int, because we're doing a confidence interval. Okay, if you select that on your calculator, okay, it's going to ask you for 3 inputs. It's going to want to know how many of the records came back with 1s as the first digit. That was 68. Okay, n, which is how many did we survey? That would be 300. Okay, and then the confidence level is 0.95. Okay, if you run that, you should see this spit back out at you for the confidence interval. Okay, if you look at this confidence interval, you'll notice that confidence interval does not contain the 30.1% that we would expect to see. And since it's not containing that, we're thinking, you know what, we probably should audit this company. Okay, what this is kind of showing you, by the way, this is how the official kind of description would be. We're 95% confident that that interval right here captures the true population proportion of expenses for this company that begin with the digit 1. Okay, and so we're saying, since that's not in this interval, this company should be investigated for fraud. Okay, now you're kind of seeing a connection here between how, oh, that's kind of cool, we can come up with a conclusion by using a confidence interval, or we could use a significance test. And the one advantage of using a confidence interval is it gives you values for that true population proportion that are plausible. Okay, as opposed to if you just do a significance test, it's really just making a decision to reject or fail to reject a certain claim. You don't really know where the true proportion lies. A confidence interval is really helping you try to figure out where is that true parameter lying, so it gives you those plausible values. Okay, one very, very important thing, lastly, is confidence intervals can only be used hand in hand with significance tests like we did here if the significance test is two-sided. And that is basically because when you're doing those confidence intervals, it is an interval, you know, between something here and here, like, you know, a 95% confidence interval. Significance test-wise, that would mean it would have to be like a two-tailed test like that. Okay? All right, that's where we're going to stop the notes here for now. As always, you guys can message me if you have any questions on anything.